So before we go ahead and get started, a brief introduction about me so that we know who we are and then who are all there on the chat as well. So for people who know me, who have been watching the Galaxy channel, might be familiar with my voice, but for people who doesn't know, who are joining the chat for the first time and who is coming to our channel for the first time, welcome. I really appreciate you taking the time. I am Kumar here. I am a solutions architect and I have been doing this job for almost close to 16 years, and particularly in AWS I have been doing it for almost like 5 years now. You can see my blog articles going all the way up to 2015 and 16. And that is not the only thing. And as I already said, in Galaxy, quite a lot of the AWS content is done by me. And I also work with the Shankar. We both work together on this channel and try to produce as much good content for you so that you can benefit from our content and take the maximum value in your professional life. And I also spend my time creating content in Udemy as well. I have a couple of courses talking about CDK, talking about security, cloud formation, automation, and those sort of things. And I spend my time in GitHub also. Quite a lot of repositories are there in my profile. If you go ahead and check in the URL that is you see on the screen, you will have different automations and different demos, different use cases. And if you're looking for challenges, there is a demo repository called AWS real-time use cases. So people quite often ask me, I am learning something new, tell me what should I do next. So if you go ahead and find a real-time use cases repository, then you will have a lot of customer use cases which you can go ahead and try and solve them. So that is about me. So let us go ahead and get started with the actual demo that we have planned for. So AWS Cloud Development Kit. So that is what we are going to talk about today. So what is AWS Cloud Development Kit? And when we say infrastructure is code, what do we mean by that? So let us go ahead and understand the underlying problem on why we need to use tools like this and what people are using today and why we cannot continue with the same thing. So let us go ahead and see those things first. So when you are talking about a modern cloud application today, it has a lot of moving pieces. Even if you talk about a simple three-tier architecture where you have a web server, app server, and a database server, there is 3 tiers for you. And if you want high availability, you are going to put it in multiple availability zones. So for that, you need your VPCs, you need your subnets, you need your security groups, you need your NACLs, you need your public IP addresses, load balancers. All those configurations are there, multiple pieces. And if you're going ahead and trying to do them manually, it's going to be quite cumbersome for you. And it is easy to get started because it's just manual. You just go ahead and click on the screen and get started. And the problem with this approach is it is not easily reproducible. Say, for example, your application is really successful in Virginia or Mumbai or Singapore, and you want to redo it, or you want to have a disaster recovery, or you want to create a dev environment so that you can do some experiments. It is, again, you need to click through all those setups. If you tear down your setup and then you want to do it again, you go ahead and click on that. And the problem with that is it is going to be error prone because you cannot reproduce 100% of the times the same things again and again. It is human nature that you can miss out some features or you might forgotten some steps, but that UI might have changed or the region might not have that functionality or the feature. So there are a lot of things that can go wrong and it becomes really, really time consuming to do it the manual way. So I would highly recommend you not to do anything manually if you're doing things in AWS. So to overcome this problem, we can go ahead and start scripting our infrastructure. So that is the next way that people move on from manual deployment of infrastructure to a scripted deployment. It might be a simple TypeScript or a Python script or a PowerShell or any type of scripting that you might do. And it takes you some way better than your manual deployments. The problems with this kind of a scripted automation is you are calling an AWS API. If you're trying to create a bucket, you're calling the AWS S3 API and saying, I want to create a bucket. But for some reason, your internet is cut off. If there is a network failure, you don't know whether that request for creating a new bucket has been successful or it has been failed even before reaching the AWS network. So how do you handle API call failures? And when that failure happens, do you retry it, or do you wait for it, or do you go ahead and manually check on that? So you need to do all this error checking in your scripting code. Instead of provisioning, now you're trying to solve network issues and other issues on your script. So you are doing more than your infrastructure provisioning. And the next problem is, how do you update them? Because all your code is in a scripted format in a file. For example, let us say you are creating a T2 micro instance and you want to change the instance size to something like a medium or an XL large. Then you go ahead and edit your script. So if it is in console, you just go ahead and click done. But if you're on a script, then you go ahead and read the script where that particular value is. Then you go ahead and make that update and make sure you have not introduced any other errors, and then go ahead and try to rerun those scripts. So again, there are some possibilities of remediating it, but if you just have one script and then have it in your desktop, that is not the best way to do it. And if you have multiple resources that you are provisioning with a script, for example, if you're building a database, usually it takes about 20 minutes for an database to come online. Let us say 15 to 20 minutes, depending upon your database size or a cluster. So you need to wait for that server or a database to come online so that you can start sending traffic from your application. So you need your scripts to wait for other resources to be ready, and then you are trying to do more things on your script which you did not intend to do in the beginning. So all these things are there. And the final thing that I don't like doing in simple scripts is rolling back. If you're building 20 resources in your script, and let us say one critical resource, for example, your database is not getting created, do you roll back all the resources, or you just keep all the resources and wait for the final resource to be redeployed? So how do you write this rollback logic into your script? So this is another problem that I always faced when I was writing scripts with deployment structures. So to move away from these problems, let us look at a service called CloudFormation, which takes us one step forward and solves some of the problems of the manual and scripted approach. So in CloudFormation, what happens is you write all the resources that you need into a template. It can be in JSON or in YAML template, and then you give it to the CloudFormation service, and the CloudFormation service goes ahead and provisions those resources for you. So for straightforward and simple, you let the error handling, you leave the waiting and rollback, all those problems to CloudFormation. So the CloudFormation will see when the database should come online. Okay, only database should be started after I have certain other resources, for example, the parameter group or a subnet group or database, or I will roll back all the services except for this particular resource or the stack. So CloudFormation can do all that for you. So this approach is easy to automate, and you can easily reproduce it, because if you use CloudFormation parameters, you can go ahead and change the region and the AMI, and it should be it takes you to a certain amount of flexibility where you can reproduce it from one region to another region. And finally, configuration syntaxes. You need to learn how CloudFormation works. If you're using a JSON format, I'm not a big fan of JSON, but it works. You need to understand where the commas come in, where the brackets come in, or even if you're using an YAML linter or JSON linter also, you need to know what is the syntax for, say, creating an S3 bucket, what is the parameters, what attributes are available. All those things, you need to understand the syntax to go ahead and do it. And even if you're trying to create a simple thing as VPC, you're typically writing about 300 lines of code if you are creating a multi-AZ VPC in CloudFormation. It works, but it is not the best way of doing things. So if we want to see some problems of CloudFormation also to be solved, let us look at the other solution that is available in the market today, which is something like a troposphere or a Terraform or a GoFormation. These are all written in native code, as you can see here on the top. Troposphere is written in Python, whereas Sparkle Formation is in Ruby and GoFormation is in Go. You can use these native programming languages to write your code and leave the error handling of if loops, for loops, and all those sort of things to the programming language itself, and wait for those API call failures and all those sort of things. So it is real code, and you can define what is your desired state. I want 3 server stack to be online. So you define the state in your code, and let the code and CloudFormation figure out how to deploy that. So it really works. But once again, you cannot have abstractions. For example, here also in Troposphere, if you're building an VPC, it's approximately about 200 lines depending upon how many ACs you have and how many rules you want. So you don't have a way of reusing things that you write. If you are creating another VPC, you just need to copy and paste all the lines of code, and there is no way that you can customize with just few parameters as possible, and there are no defaults built into the platform itself. So you need to redo all this code. So we have all these problems, and each of the tools have some advantages and disadvantages, and this is where CDK comes in to help you to solve some of these problems that we discussed right now, whether it is API failure or rolling back or making sure you're waiting for some other resources or you want to reuse some resources. So CDK helps you to solve all these problems. At the heart of CDK, you have something called as constructs that you see at the center of your screen. And constructs are nothing but a 1:1 mapping to your AWS services. So for each AWS service like S3 or SQS or a Lambda, Amazon has created an construct that you can go ahead and use in your stacks. So when I'm saying a stack can be made of multiple constructs. It can have only one construct or 10 constructs. It's depending upon how much you want. And of course, this stack is given, multiple stacks will make up in your application. And remember, CDK ultimately creates a CloudFormation template for you. But how do you create the CloudFormation template is the funny part. You are going to use native programming languages. CDK is nothing but a software deployment framework for modeling your cloud infrastructure with reusable components. You can use CDK in different languages. As on today, it is supported in TypeScript, Python, JavaScript, Java, C#, or any of those .NET based languages. But these are the 5 that are officially supported. But if you are familiar with the .NET, there are other .NET framework languages that can also be used. So let us go ahead and see what CDK itself offers. What are the core components of CDK and how we can use it? So just a summary of all the languages once again. So TypeScript, JavaScript, and C#, Java, and Python. And this is open source framework. So if you think that you have a favorite language that needs to be supported, you can go ahead and join the GitHub community where AWS has published the code and very active there. You can go ahead and define your use case, and they are very receptive to feedback, and there is enough requests from a particular language, then they will go ahead and create a supporting constructs in that language also. So keep watching that space. So again, diving into the components that I was talking about. So when you are talking about a CDK application, you have constructs at the core of it, and the stack is made up of multiple constructs. And when you're talking about application, it can be multiple stacks. Why I keep referring to stacks is in a 3-tier application architecture also, you can have a network stack separately, and then you can have your application stack separately and your database stack separately. So all these 3 stacks will come together to create your CDK application. So let us call this as the core source. You write this in Java or Python. So you have your source code. Then what you do is you use a command which is called as a CDK CLI. This comes built in with the package that Amazon offers. Once you install it, you will have a CLI for a CDK, and the CLI has a compiler built into it. So when you run the command CDK synth or a CDK ls, what it happens is it takes the code, compiles it, and it synthesizes an CloudFormation template. So this is the key area where your native language code, which was written in Python or Java, gets converted into an AWS CloudFormation template, which is confidently can be deployed into the AWS service. And you have another command called CDK deploy. So when you run the CDK deploy command, automatically CDK will take the template that was created just now and passes on to the CloudFormation service, and the service will go ahead and create the template for you. And it will also wait for the rollback triggers, or it will wait for the updates and get all those information back into the console. So if you're doing things on your laptop or in a Visual Studio Code or any other IDE environment, all that information gets feedback to your local environment, and you should be able to see the status in real time. So in a short while, when you're doing the demo, I'll show you how that works. So in short, CDK is nothing but a library of high-level resource constructs. Why we mean that high level is, let us say there are three levels. The level one is CloudFormation mapping. So if you are trying to create a bucket in CDK, you have a 1:1 mapping for CloudFormation. So you can take the exact CloudFormation resources and start using them in your CDK stack. That is also possible. And let us say level 2, where Amazon has created constructs for you, which is built on top of CloudFormation, so that you don't have to fill in all the default values. For example, the best use case again S3 is the minimum requirement is giving an S3 bucket name. But if you know S3, you have configurations for what is the encryption keys, whether you want versioning to be enabled, whether you want logging to be enabled, whether you want replication to be enabled. So there are quite a lot of default values. So Amazon has created an construct which has same defaults, which is taken from best practices from other users. Another better example might be a VPC, where you have ton of configurations that will be given for building a VPC, but the construct that is provided by Amazon takes only the CIDR range, that is the IP address range that you want for your VPC, and you just go ahead and say, I want 2 AZ deployment. With just these two pieces of information, you should be able to deploy and production ready VPC, which is following best practices, which is learned by other customers. So that is what the L2 constructs is. And the L3 constructs, that is level 3, is something that you create of your own for your company. Say, for example, you in your company says that all EBS volumes to be encrypted. So you can go ahead and create a construct which will create an EBS volume, and whenever it creates a volume, it will encrypt them with a particular key, or it will make sure that certain tagging is also attached to that instance or volume. So that is what a CDK is. At the high level, you have constructs and you have default best practices attached to them, and this is all componentized, meaning you can choose whichever constructs you want, and then you can combine them in the way you want, or you can combine multiple constructs and create your own components and reuse them. So this way you can achieve highly complex architectures also. So a quick summary of what is CDK. CDK is going to use your familiar programming languages like Java, C#, Python, Node.js, and TypeScript. You are going to have high-level constructs, so then you don't have to remember all the default configurations for an VPC or an EC2 instance or an S3 bucket. So you have high-level constructs with same defaults, and which helps you to accelerate your deployment of infrastructure. So no longer you are talking about infrastructure as code. We are going to change the things as infrastructure is code. It is no longer as code, because you are writing them in your native languages. So this is one thing that I want you to take it in mind. If you are still doing scripted approaches or still doing manual approach, the world is moving really fast. In the last 6 to 8 months, I have seen the CDK version move from, say, for example, 20 different minor versions have been rolled out. So that is how fast CDK is getting evolved, and customer tractions is also getting added slowly. So a lot of people are adopting it. And when I was talking to a customer recently and I showed them the power of CDK, the team started using it in the next week. That is how fast the adoption is, because people who are using CloudFormation, they just find that CDK is really, really helpful. And this team is not something, the customer that I'm talking about is not someone who had a lot of experience in AWS, but this team was struggling with their CloudFormation experience, but they had some Python knowledge. And once I showed them that you can use the Python knowledge and use CDK directly to create those resources, they were very happy and started adopting it and started using it. So going to the workshop itself, let us go ahead and see what we are going to build now. So quickly I'll walk through what we are going to build, then we'll go to our Visual Studio Code and see how we can actually build it in our own environment. So what we are going to build now is a simple multi-person chat application, so that you all can chat with each other once the application is deployed. So the architecture is going to be something like this. What we are going to do is, first we are going to create a Fargate cluster. If you are not aware of Fargate cluster, it is a serverless container orchestration platform. You don't have to define how many EC2 instances, master nodes, slave nodes, those sort of things when you're typically doing with Kubernetes. You just define your container definition, then Amazon Fargate cluster decides how to run it, where to run it, and attach a public IP or not. So we are going to create a cluster, and inside the cluster, we are going to create a chat service. And inside this chat service, we are going to attach a task definition saying, this is the container I want to run, and this is the port number I want to run. For example, the port number can be 3000 or port 80 or port 443. And then you will attach that chat service and the task definition to our cluster. And we will also front end it with an application load balancer, so that if there are multiple tasks that are running, because our chat application has grows, you will have more and more containers running, but you want a single entry point for all your containers. So we will attach an application load balancer. And once we have the application load balancer, obviously we will have a DNS endpoint, and we can use it to connect to our application and talk to it. And remember, when we're talking about application load balancer or a cluster, we need an VPC. I have not put it in this diagram just to make it clear and easy to understand, but we will also be building an VPC with just 1 or 2 lines of code. So once we have this deployed, this is our user interface. So we will have an user interface which is going to ask us what is our name, what is the user going to be, and once you fill in, then multiple people can go ahead and chat with each other. There is no state management here, but this is a simple demo application to show you how fast a CDK can work and how we can go ahead and get started. So this is on what we are going to do. Let me take you to my terminal, and let us start building it there. Just a quick confirmation on the chat. You are able to see my Visual Studio screen now. So far good. If you can see my Visual Studio screen, just confirm that on the chat so we can get started. Okay, fantastic. So let me just go ahead and open another terminal. So the first thing is, this is my local laptop. I already have installed the CDK. So if you don't have CDK, the way to install it is through npm install. Let me just make sure that I'm typing it correctly. AWS-CDK. And you need to have obviously npm. So if you don't have npm, just go ahead and check out how npm is to be installed for your operating system, because the installation differs for Linux and Windows and Ubuntu and different flavors. And once you have it successfully installed, you can just confirm npm is working. And then if CDK is also working, you can just go ahead and say CDK -- version. Fantastic. So the first thing I'm going to do is I'm going to create a directory, and I am using an Mac laptop. It's Linux based. So all the instructions that I'm going to show you are based on this laptop. I do not know how to do that in Windows or other platforms, but it should not be too difficult because a lot of people use different platforms to do this. So I'm going to call this as a CDK workshop, and let us dive into that directory. And so far we have not done anything. We just installed the CDK and created a workshop. And for initializing the repository, what we need to do is we are going to choose we are going to say CDK init. This is going to create our default temporary template structure for our application. So CDK init app -- language Python, and I'm going to write a CDK in Python language. If you are familiar with some other languages, you can go ahead and use that language also. So you just change in the -- language, you just go ahead and say TypeScript Python or TypeScript Java or any language that you want. So if you're familiar with the Python, you see that it has automatically created my virtual environment also. So what I'm going to do now is I'm just going to add my this particular workshop directory into my workspace. I'm using Visual Studio Code. You should be able to use it in PyCharm or any IDE that is you are familiar with. So let me just go ahead and quickly add my directory there. Looks like it's not added. Let me try and add it again. Okay, it should be visible now. Yep. So I want to point out there is another application directory that is already open here that you can see here, that is a CDK demo app and then CDK workshop. I will go ahead and use a CDK demo app later, but the one that we are going to use for some initial discussions are going to be this CDK workshop only. So when I create the init, what it does is it is going to create this default template directory. You don't have to worry about what files is there, what needs to be there, what is the structure. It automatically creates them for you. And the most important files I'm going to walk you through is app.py. Let me fold this. So automatically it just creates a template structure. You don't have to change anything here. The most of the code that you need to be writing is under the CDK workshop. You have this CDK workshop.stack. As of now, you can see here the code is empty. And if you remember, with any languages, you need to import some libraries. In this case, a CDK core library, or let us say I want to use EC2, for example. So then in the case, what I'm going to do is AWS underscore from CDK.aws underscore EC2 import. I can just say EC2 here. So the reason it says the squiggly line is I have not installed it in my Python virtual environment. So if I go ahead and say AWS underscore CDK dot AWS underscore EC2, let me save this, and I'm going to activate my virtual env environment. Bin activate and then pip install -r. What this is going to do is this is going to read my requirements file and then install all the dependencies for me. So automatically the necessary dependencies, like if I want to use load balancer or Fargate cluster or an ECS pattern, then you can go ahead and add them all in this requirements file and then run the pip install command. It will go ahead and install them. So once I have that installed, then I can come here and start using them to build things. So the reason that I want to do all the typing here is I want to save time for you guys and myself. And I don't want to be embarrassed by typing a lot of incorrect code. So that is why what I've done is I have built the app already and I have commented out most of the code. For example, I'm just opening the other directory here under requirements. You can see here I have added the EC2 because we are going to use the VPC, which is from EC2, and we are going to run a Fargate cluster which requires the ECS constructs. And likewise, I have also added the ECS pattern because that allows me to build and load balancer along with the task services and everything. So let me take you to the actual code itself. The actual code is in the stack.py file, and you can see here everything is commented out. Let me just jump back to my okay, let us do it here itself, not a problem. So let me just go to CDK demo app. Let me clear my screen. So right now you can see here in this code, if I do on CDK ls, it will show me the app.py file. Oh, I crashed it. Let me just close this. I just crashed it. Let me go again. CDK-demo app. Let us activate the environment again. This is very, very important. If you're using Python, you need to make sure that you are activating your Python environment and then you are going ahead and building things. Are you able to see the terminal? No? Okay, let me just resize it. Okay. Okay. You are able to see my terminal now? Okay, I'm just going to slow down a bit. So, just to be sure, I am in the directory of this repository, CDK demo app. And under this app, we have an app configuration, something like this. We have an CDK demo app, and I'm going to call this a CDK demo app 2. Let me just remove the 2. I don't need the 2 now. If you want to have different stacks at different names, then you can just add values. So in this case, I also added tags. You can see here, I'm just adding different tags of my GitHub profile and my Udemy profile and things like that. So all these tags will get added to all the resources that are going to get built in my stack. And just following through again, we saw the what you call the constructs. These are the 3 constructs that we are adding, and this is my stack file. And in the stack file, as of now, I'm just building a VPC. You can see here, for building a VPC, it is just one line of code. I'm just saying from my EC2 construct for VPC, scope it to this particular stack, and I'm going to call my VPC as my VPC, and I'm just saying max ACs of 2. This is all the information that I'm going to provide to AWS to create and stack for myself. It is going to define what is my subnet range. It is going to define what is my NAT gateways that are required. It is going to define how many ACs are available. Say, for example, if I'm deploying it in Virginia, I have close to 5 regions. But if I'm going to deploy it in some other region, like in a Japanese region, there might be only 2 availability zones available. I'm sorry. I'm referring to availability zones. So it automatically is going to find out what availability zones are there, and it's going to find out how many subnets are going to create it. So the first step is, if I do CDK ls, what this is going to do is it is going to read my entire app stack file, synthesize it, and if there are errors, it is going to give me that error. If everything is good, it is going to say this is your stack that is ready to be deployed. So if I go ahead and do a CDK synth or synthesize, which is the short form, synthesize is the long form and synth is the short form, it is going to spit out the entire CloudFormation template on your screen. So you can go ahead and check it out. So in this case, we will also have when you're deploying it, you will also have a folder. Though here it is, I can see this. Under cdk.out, you will have the entire template stored, and then you can use this also into your CloudFormation service. So the entire stack is here. So what I'm going to do now is I'm going to take you to my browser and walk you through my AWS CloudFormation console and the account, and then we will see what resources are there and what resources we are going to build now. So here we are in my AWS console, and you can see here there is only 2 stacks right now. The CDK toolkit, I'll talk about that in a short while, but this is for a different stack that I'm building out for checking out few things. But if I take you to my VPC service, let me refresh my screen. As of now, there is only one default VPC. There are no other VPCs in my account, so there is no magic here. This is a pure live demo that we are going to build everything from scratch. So there is only a default VPC. You can see here, that's the one. And if I go to my ECS cluster, likewise, there is no clusters defined here under cluster definition. You can see here, there's nothing there. Likewise, under EC2 also, I'm not running any instances or anything like that. That requires to be modified. So let us go ahead as a first step and deploy our VPC. So I'm going to clear my screen, and I'm just waiting for the screen to refresh so that everybody can see it. So let us go ahead and remember there was a CDK toolkit app was there. So what I'm going to do now is let me just pull up my screen. For some reason the console is not completely visible. I'm just pulled it up all the way up. So if you are doing CDK for the first time, you need to ensure that you are bootstrapping your account. The bootstrap is nothing but is the one that creates the S3 bucket in your account. So the CloudFormation template will be stored there and deployed. If you are using Lambda functions, you need to store the source code and other things. So you need to have your Bootstrap stack deployed as the first step. I have done it already in my account, but just to show you, I'm just doing it again. So what happens is, in this case, the CDK Bootstrap is going to check whether there is an already an stack. If it is not there, it is going to deploy it. If it is there, you're just going to say there are no changes. So once you are ready with the Bootstrap, I'm going to show you the two ways of deploying it. One is if you have only one stack. In this case, we have only one stack. If you have multiple stacks, then when you're deploying, what you need to do is you can go ahead and say CDK deploy and then followed by my stack name. But I don't have multiple stacks, so I can just type CDK deploy also, and it will go ahead and deploy it. So what is now going to happen is it is taking my CloudFormation, it is creating a stack set, and it is going to upload it into the S3 bucket and then go ahead and create a stack in my account. So let me take you to my CloudFormation service. So here, let me go to the CloudFormation service and refresh my screen. You can see here the CDK demo app is getting built, and remember, we are just deploying a VPC right now. We are not doing anything else. And if I go to my events section, you can see here it is going ahead and creating my private subnet, public subnet, and all those things. And under template section, you will have the complete template available for you. And whenever there is a changes, you can go ahead and check your change set also. So because we are going to do a lot of changes now to the same stack now, because we are going to add a cluster, we are going to add a service, we are going to add a task, and all those changes also you can go ahead and see, and all the template information is there. And once the stack is deployed, we need our application load balancer URL also, right? That URL will be published to the output section of our stack, and we should be able to pick it up from here. So let me quickly walk you through my VPC section also, so that we will see what is getting built. You can see here we have a CDK demo app VPC, which is named as a my VPC. And what I'm going to do is I'm just going to filter it. Let me refresh my screen so that it comes up there. Now let me refresh it here. So I'm going to filter by my VPC, and if I go to my subnets section, you can see here I have multiple subnets created for me. For some reason I'm not expand this, but that should not be a problem. You can see here there are multiple subnets, and each of those subnets are having different ranges, and you can see this is under AC1, and likewise you have some of the subnets created on the other availability zone. I will also have route tables created for my private and public subnets and my internet gateway. So I have a complete multi-AC subnet that is created for me, including NAT gateways also. If I go to my NAT gateways, you can see here there is a NAT gateway attached, and this is my NAT instance that is running, and there are two NAT instances for each of those availability zones. So you have high availability for your NAT instance also. If you don't want that, you can go ahead and tell the VPC constructs in your template and say I want only one NAT, and automatically it will go ahead and deploy one NAT. So now we saw our VPC is getting deployed. I think the stack should have been done by now. Probably not. Yeah, okay, I see it is complete. Let us go back to our Visual Studio Code and see how to build the cluster itself. So let us get back to our Visual Studio Code. So I can see here the update for my stack has also come here. You can see, as I mentioned, all the information from your CloudFormation service gets fed back into your console, so that you can see the information back in your console itself. Let me see if I can somehow reduce the screen size, because on my screen I see it as completed, but for you guys it is not able to be visible, I think. Let me see. Just give me one moment. I'm just going to readjust my Visual Studio Code so that we can do it. I think now you guys should be able to see my complete Visual Studio Code terminal window now. Just a quick confirmation on the screen chat window if you can see my full terminal up to the bottom line. Okay, fantastic. So you can see here the status of the stack is deployed here. So let me just go back to my stacks.py, not this one. Let me close this one. Let me close this one also, and this one. Okay, let me open it again. So far, if you notice, everything else is commented out. In Python, you just use the hash to comment it, and you can see here, I just built only the VPC. So what I'm going to do now is I'm just going to build only this cluster. And for this also, I'm going to use the ECS constructs, and I have already imported the ECS constructs. So I'm saying ECS.cluster within the scope of this stack, create me a cluster which is named as my cluster, and then call this as VP and build it inside this VPC. So just to be sure that I'm building it right now, I'm just going to call this as a CDK workshop cluster. Let me just remove the special characters to avoid any problems. I'm just going to save this and do a CDK ls to make sure that I've not made any other errors. I'm going to check that. And once this is done, I'm going to do a CDK synth also. That will also be another confirmation to make sure that I'm not making any other errors. And once this is successfully coming out with a prompt, I will go ahead and deploy it. And before deployment, I can show you one more command that is available for us to know what is going to get changed. So we can do something called a CDK diff. And when you do a diff, what it's going to do is it is going to show me the difference between what is being deployed and what will be deployed. It is just like your git command diffs that you might be familiar with if you're programming. So let us do the diff, and it is going to give me a good nice comparison of that we are going to build a new cluster now. So it is running, and you can see here it is saying that it is going to build a new resource called as AWS cluster, and that cluster is going to be built. So let us go ahead and deploy this. So while this is triggered here, let me take you to my CloudFormation console and see what is my cluster getting built there. So here, if I refresh my screen from create complete, we should be very short while we should be able to see this is an update in progress, and we should be also able to see in the events section what events are getting created. You can see here there is an update in progress, and it is already created my cluster. So let us go to our ECS and refresh our screen. We should be able to see in CDK demo. You can see here there is a CDK workshop cluster that has been created. So under this cluster, there is no other resources because we just created a cluster. We did not say what service to be running, what task to be running, all those kind of information. And we also did not mention what type of cluster we want, whether a Fargate cluster or a EC2 cluster. So all of this are empty. We are going to build it right now. So let us go back to our console. Back to our console, you can see here there are just 3 more steps. So the first step that I'm going to do now is I'm going to create a container task definition. And when you're talking about container task definition, you need to mention what type of container that you want to run, whether you want to run a Fargate container or you want to run an ECS container. So in this case, I want to run it at Fargate so that I don't have to worry about building EC2 machines, maintaining them, patching them, updating them, securing them. Amazon will automatically be updating them for me. Somebody mentioned that it is in a smaller font, so my recommendation is to go ahead and increase it, your resolution. I have also increased the font size. I hope it is big enough. Let me just see if I can add one more font size. It will be otherwise it way too big for everybody. So I'm just resizing it. So in this case, I'm creating a task definition, and this is going to be a Fargate task definition. And I'm calling this as task definition itself, nothing else. And inside this task definition, what we are going to do is we are going to inform what container we are going to run. So let us do these two steps this time. And remember, see here, I just commented out these things. The reason for that is there are multiple ways you can give your container definition. For example, you can have your Docker file locally in this repository itself. I can create a Docker file and then mention the location for my Docker file. So automatically, if you have ECR and if you have Docker installed in your laptop, that is local laptop, like I'm using Visual Studio Code. If you have Docker installed, CDK will leverage the Docker and build the Docker image, push it into your ECR container and use that container image. So that is also possible. So the second method is if you already have an ECR in your account, and what you can do is you can just mention the image here, and then it will automatically pick it up from your account credentials and from your registry automatically. The final method is this way is what is going to happen is you can also pick it up from Docker Hub. That is what I'm showing now. I have this image in my Docker Hub, and I'm going to pick it up from my Docker Hub and I'm going to deploy it. So what this step is going to do is it is going to create me a task definition. It is going to create a service, and this is the part where it is going to add me the port mappings, because when you're running Docker containers, you are running some application. If it is a web server, you typically use a port number 80 or 443 depending upon whether you want HTTPS or HTTP. And in this case, I'm using a chat application which is running it in Node.js. You don't have to worry about what the application itself is written on, but that application uses the port 3000. So I'm going to open that port also. So in the interest of time, what I'm going to do is I'm going to uncomment this also and deploy everything. So let us just uncomment this and let me walk you through. What it's going to do is it is going to take this application container and put it behind an application load balancer. So it is going to create a listener. So the load balancer is going to be accessible from my browser. So I don't have to worry about putting the port as 3000. So automatically the translation between port 3000 to 80 is done by my load balancer on my Fargate host. And I'm going to assign a public load balancer so that it is accessible from the internet. And for my container itself, I'm saying don't assign any public IP addresses. So that is what we are going to do now. You can see here there's nothing else. Let us go ahead and do an CDK ls so that we can make sure there are no other errors that we have created and be confident in deploying it. CDK synth, and let me also do a diff command and see what happens. CDK diff. And let me just pull up the screen so that we have multiple changes. Let us see what are all the changes that are getting prompted here and shows up here. You can see here it shows me a list of things that are getting created. So this is the diff command that is started here, and it says that it is creating a task role, because if you remember in AWS everything requires the permissions to run, because we are going to run a container which is going to receive traffic and do some processing. The tasks require and role, and that is going to get created automatically for me. I am not worried about what permissions are required, what is the most least privileges, because as I mentioned earlier, CDK is built for sane defaults and best practices. So the permissions given to this task role is as minimum as possible so that it can do the job it is required to do. And the next step is security group changes. We are opening port 80 and 3000 for the load balancer and the container itself. So that is what is shown here. And the rest of all the changes are listed here. And we are also creating a load balancer. So we are going to get the DNS name published in our console as well. So let us go ahead and trigger the deployment. And this deployment is going to take approximately about 4 to 5 minutes, if I'm not wrong, because we are going to pull the container image from Docker Hub and we are going to run it. And if you remember, or if you use load balancer, it is going to take some time for the registration and then the health checks to be successful. And if you remember, I have not mentioned any health checks. What is the frequency? What ports do I check? So it is all takes the same defaults. It pings the IP address that is in the container, and if the container is responding, then the health check is marked as successful. So while this is getting deployed, let me take you to my CloudFormation console and see what is happening there. So I can take you to my CloudFormation console, but there is not going to be much. We are going to see a lot of events that are getting prompted here. You can see the task definitions created, but let us go to our ECS itself and see what is happening here. So if I refresh my screen, you don't see anything here, but in a short while, we should be able to see our service come up. But in the meantime, our task definition is the first step that will get created. You can see here there is a CDK demo app task that is getting created. Let me just open it. Under this task, if I go ahead and choose my app container here, you can see here this is the Fargate chat app and the port 3000 mapping, and all that information that we gave in our console is being populated here, and this task is getting created as we speak. So let me go back to my and if you remember, I spoke about tagging, and if you see my stack, I have not tagged them individually, but I created tags at and stack level, and automatically all the resources in my stack is going to get those tags. You can see here in this case, even the task definition is having the tag. Likewise, if I go to my cluster, my cluster tagging will also be there. So if I go to my cluster and go to my tag section, you can see here that is also tags. But let us get back to the services section. So the tasks are getting built. We should be seeing the task start running here. So it is doing all the background processing. Meanwhile, what I'm going to do is I'm just going to go ahead and check whether the load balancer has been triggered, and we are building an application load balancer. So let us go to our load balancer section. And you can see here there is a load balancer that is getting built here, and under listeners there are no listeners, so my CloudFormation is still working through all those processes. Let me just refresh my screen here. So it's still working through things. So let me go to my target groups. This is where the fun part is going to happen. Under target groups, we will see some container images. So in this place, we will see at least one container coming up, and the status will be changing depending upon the state of the container that is coming up. So as I said, we are going to wait for a few minutes. So if you have any questions in the meantime while the stack is getting deployed, I'm happy to answer them. Just go ahead and type them in the comments. I am looking at the comments and trying to juggle between my screens, so I will answer them. So there is a question about, is it available as an open source? Yes, most of my code is open source. I already gave the GitHub repository or my repository in the beginning. Just I can give it to you again, so you can go ahead and find all the code that we are using here in my GitHub repo. So I can see the task popping up here. You can see here the task status is already come, and it is showing a status as running. So let me go to my service and see what is the health check here. You can see that is completed. And let me just go back to my CloudFormation and check what is the status. It is still update in progress. Let us go to our load balancer and check out. You can see here in load balancer, I also has reporting as healthy. And if I take you back to my Visual Studio Code, we should be able to see the URL for my load balancer also given here. I should be able to pick it up from my CloudFormation also, because I have written it in the way, and CDK also automatically publish the load balancer URL whenever you are creating something with an usable information. So in this case, this is the URL So fingers crossed, if everything works, this should be prompting me with an username. What I'm going to do is I'm going to put it in the chat window. So I want some of you guys go ahead and add your name and just say hi so that we can confirm that this is working at scale from different people. I'm just going to say K here and then log in, and let us see. Hello everyone, welcome to CDK workshop. So you can see here there are different people from different places, and you are able to communicate with each other. It is like a chat lobby that you can create with a very simple 50 lines of code hardly that you have written here, and we can have a chat lobby. There is no state management because this is a demo app, and you can use it. So let me just quickly go ahead and check my stack. So I just got prompted with the DNS URL. We already saw the DNS URL, and it is completed and it is running. So that is on the demo part. So I'm done with my demo part. So quickly going back to my presentation here that I wanted to share earlier. So we saw so far how CloudFormation can help, and how CDK can help, and how it can alleviate some of your problems. So you no longer have to just listen and learn to me. So what I've done is I have made all the code available to you. I have also created an a Udemy course which talks in detail about CDK, about how to set up, what are the things that you need, how to set up your IDE, what is the prerequisites, and every single step of CDK has been explained in detail in the Udemy course. And this course is designed for people with beginner knowledge in Python and AWS, and you can take it all the way into professional. But there is a minimum requirement that you need to have AWS knowledge, and you need to have some kind of programming knowledge to start with this course. Keep that in mind. Because this course does not deal with the AWS, this course deals with the CDK. So once you are familiar with the AWS, then if you're looking at automation, this is the course I would say go ahead and take it. And there is a limited time special offer for you because you guys have decided to spend your Friday evening with me, and this offer is available only for you guys. It is not going to be available for anybody. If you go ahead and the course link is there in the description of this video, and if you go there and use this code that you see on your screen right now, then you will get some discount on the price that you see there. So this is only for you. This is not going to be published anywhere else. So make the best use case of that. So if you have seen that, I'm just going to move on to the next screen, which is say Q&A. I am available for some time to answer any of your questions that you might have. So there was a question about I want to use custom names. Yes, there are possibilities of adding custom names for your stacks. Then you should be able to use that. And most importantly, I believe in the strategy of using your resources as cattle, not as pet. So I would not be too much worried about ABCDXYZ as my web server name. As long as my web server is up and running and my health checks are working and my KPIs are met, I would not be worried about it. But if you want to do that, then there are many ways of doing it. Yes, it is possible. There is a question about can I attach persistence volumes? I assume this question is related to EKS, Kubernetes, I think, because if you're talking about EBS volumes and EC2 instances, then it is possible. But if you're talking about persistent volumes in Fargate, you can use EFS, and today it is possible to attach an EFS as a persistent storage for all your containers. So you're not a big fan of EC2 and you want to go with EC2, why not? As I said, ECS allows you to compute capacity, whether it is EC2 or Fargate. You can go ahead and add additional lines of code and choose the appropriate For example, we used an ECS pattern which is based on Fargate. You can just change the word Fargate to EC2 and you should be able to do that. Of course, you need to change few other things, but the documentation will help you to do that, and it is possible. So there is some question about is it possible to create pipeline GitHub using CDK for deployments? Yes, I'm working on an demo in my repository. I'll publish it soon, which creates the repository and creates the pipeline also. So it is like a self-building code, self-assembly code. The first step is creates the code commit, and once you have the code commit, you publish your code there, and the next stack will be creating a code pipeline, and using the code pipeline you can deploy your code also. So it is possible. If CDK has some lambdas, then we should run a CDK stack only once and handle the deployments of the lambda separately, or we should combine CDK infra and application together in one stack. Well, it depends upon what is the lines of support or segregation you have in your organization. So who is supporting lambdas, or who is supporting platform, who is supporting application code. So based on that, you should decide who is owning which stack. So if you have a different team which does the deployment, then they can create a construct, and as an organization they can share the construct to you, and then you can use that construct to deploy your lambda, and you can still manage the application code that is deployed through the lambda. So it is depending upon how your organization wants to do it. If you the team is it is like a typical DevOps team who does both the dev and ops, then I would say keep everything together. Can we integrate Jenkins with Stack? Yes, why not? Code commit can trigger a Jenkins job, that is possible. The Udemy course link is in the description of the video. Just if you scroll below the video, you will have a description section, and the first link that you see there is the Udemy course. What is the preferred programming language to work with AWS? I am a Python fan, so I would say Python. So apparently people are not able to find the Udemy link, so just going to go ahead and say the link here on the chat window. Let me pick up the link. Meanwhile, if there are any other questions, we can take it up, check it up. If not, we will go ahead and wind up for the day. Yes, we can do Kubernetes. There are many ways of doing Kubernetes. Kubernetes on EC2, EKS, Fargate on EKS, many ways. I would say start with EKS. So there is a question about OpsWorks CloudFormation CDK. Well, what differentiation? OpsWorks has a different requirement. It is a more configuration management tool, not a provisioning tool. You can do it, but it's like using Ansible and Chef for doing configuration management and provisioning also. So whereas CloudFormation is purely a provisioning tool, CDK is also a provisioning tool, not a configuration management tool. So CDK uses native languages. None of the other platforms use native languages. So it depends upon where do you want to start. We are using ECS for deployment, get the code from GitHub, and deploy the Docker, blah blah blah. Probably you need to write it in a more clearer way, or you can email us with your question so that we can see how we can do it. Yeah, Galaxy has quite a few courses on DevOps as well. So you can check out those courses, which is under galaxy.thinkfig.com, or if you go and search for udemy.com/galaxy, courses/galaxy, you will be finding the DevOps courses as well. We don't have any courses for EKS and Fargate, but my repository has enough information on Fargate and doing things with Fargate. And particularly this CDK course has at least 3 or 4 demos using Fargate for multiple use cases, like one that we see here. For people who might not know, YAML is not a language. YAML is a format. It is, although the name is quite misleading, saying yet another markup language, YAML is not a language of its own. It's just in format, just like a CSV or an Excel file, or it doesn't do anything unless you have an engine to process it. Okay, looks like we don't have any other questions. Then we can wind up for the day. It's about 1 hour and 10 minutes. Thank you very much for joining here. If you have any other questions that you have, then put them in the comments, and one of our representatives or somebody should pick it up and answer it for you. Thank you very much, guys. Have a good Friday evening, and see you in the next workshop.